All right, what I want to talk about in this module is the MVC pattern. Um, Overall, we'll talk about MVC. We'll talk about a framework in Node.js called Express, and we'll talk about some view templating that'll go along with Express in order for us to implement the MVC pattern. But in this first talk, again, like I like to do, I want to start conceptually with an overview of the motivations of the MVC pattern, where it came from, its overall structure in a language and framework agnostic way, and then next one we'll move into what we do with a framework in order to implement it. So three key concepts I want to talk about in this video: interior architecture, separation concerns, and model view controller. Most of model view controller, but I do want to talk a little bit about some of these other buzz phrases and try and clear some things up, if you will. I hear terms like this a lot, and folks kind of throw them around, don't always know what they mean or know when to use them appropriately. Things like end-tier architectures, separation of concerns, wedding cake architectures, layered architectures, things like that, and the model view controller pattern, and a number of variants of the model view controller pattern as well. In fact, we'll do a few more of those as the class goes on. Three-tier or n-tier architectures are deployment architectures. And what they are is they're the runtime view in Crucian's 4+1 architectural model. I don't have a diagram. Well, let me start off with one of my wonderful scribbles. An n-tier architecture refers to having some software components. Software component 1, software component 2, and this is the abstract discussion, and mapping them onto physical nodes. And in UML, a node is literally written as a cube, a processing node. All right. So how you map these and deploy them onto a physical runtime space, which component goes where, maybe there's duplicate copies, it's horizontally scaled, and so forth. These are all processing nodes or computers or servers. Okay, that is referred to as your deployment architecture. What we're talking about when it comes to an n-tier architecture is a typical arrangement is this wedding cake I was mentioning, this layered structure, right? You have the client tier. What are these things? These things are, PCs, mobile devices, and whatnot. Workstations, for web applications, anything with a browser, really. Then you would hit a physical tier deployed of your HTTP servers. And these are physical boxes with IP addresses and so forth. And then you may hit your application servers of some kind, and these will be deployed. And this kind of layering that you see, which is again a common metaphor for web application architecture, is these layers. And up here we may have different services like databases, mail servers, outside connector integrators and B2B systems, whatever. These things all have to run on different machines, and they all have different computational profiles, is the point. So the systems analyst or operations viewpoint is how, what is going to be computationally running, let's say, in this application server, and therefore how many CPUs does it need, what CPU power, how much memory, how much disk space, how fast, how low end, how high end, whatnot, do you have to go through it. Now, in a traditional architecture, this mapping exercise was all done via capacity planning for your peak capacity, and you would buy your own iron, you'd buy your own systems to go run through these things, and run them in a rack-mounted space you might rent, or even if you had your own server room. Now, nowadays, a lot of this capacity planning is done on the web, meaning that this application server, and for us, application server, this could be our Node.js, by the way. This could be a Tomcat if it's a Java one, right? This could be an Apache or an Nginx or something like that, right? This could be an Oracle database here somewhere. Now when you run these things on the cloud, first of all, you're not worried about mapping to a single specific physical server. You're planning for how much elasticity, how much of that up and down scaling that you require to do. But you still have to figure out what talks to what. I mean, even when you do it on the cloud, you still have to figure out which one of these tiers talk to what, and roughly how much capacity you're going to be running through there, because it's going to affect your cost model. You got to figure out how much you want to pay for these different services. Maybe you want to put a maximum cap on it when you go provision the cloud. Typically, there are maximums that you set on things, so you understand the service level agreements and the like. And again, this is not a course on cloud computing, although that has become more common, if not the majority of deployed web applications now go on the cloud, as opposed to classic build your own rack mounted type systems, as they're called. But the point is, from the term N tier comes from this run. This is all runtime, right? These are all devices and processes running at runtime. So the N tier is this 1, 2, 3, up to N, however many tiers that you need here. And where this, tier 1 talks to tier 2, tier 2 to tier 3, tier N minus 1 typically talks to tier N, type of thing in that layered style. Again, tiering isn't as common as it was before, but still kind of the classic architecture. So you still hear this N tiering thing going on. It's not a software concept. It's a physical deployed architecture concept. That's the main thing I want you to know about that buzz phrase. Separation of concern talks about the concerns of an architecture. I'm going to talk about that next, and we are going to talk about the model view controller pattern. But that's all I'm going to talk about N tier. But again, I want to make sure tier is an operations term. Separation of concerns, that is a term a software architect's going to use when they're laying out a system, a web system. Model view controller is something that all coders talk about. Team leads and their coders talk about. Everyone should have an understanding of how the model view control pattern is realized in whatever technology base you're using in your organization, right? When you go out, if you develop web apps for a living, you could be using any number of different technologies. Yeah, maybe Node, it could be Spring, it could be Django. I mentioned that. You could be front end centric and using Angular and React and all these other technologies. In just about all of them, and whatever way you put them together, you're going to be talking about separating concerns, where the responsibilities of the system are, and you're going to talk about how the model view control pattern is realized, or its variant, because every web framework at some point says we do MVC. Okay, and that's why it's so important, and that's why it's an important topic for this class. So let's move forward. Let's talk about separation of concerns and then model view controller. Web applications typically have three important aspects, this term aspect or concern. Three things they're worried about, three broad categories of responsibility that the system has to have. At the bottom here, presentation. Presentation is rendering, right? How something is displayed to the end user. And that may seem obvious to you, but there's actually a lot of different ways that you can display information to an end user. So the rendering concern is, what technologies are going to use there, and who's going to be responsible for it as well. The business logic is the goods of our organization. This is organization value. This is that thing that is independent, right? This is independent of apps, of specific apps. This is the part you want reusable. This has things like your domain objects. This has things like common business rules that different code have to use. And we talk about the web as adapter, right? We've talked about the web as adapter plenty of times. So I know I've drawn this diagram many times where you talk about your web app here, but accessing some business logic, but through a browser. But you could have a lot of other things. You could have a mobile app here talking through an API to the same business logic. You could have an old green screen terminal, really old 70s kind of thing, talking straight into the business logic. All right. Business logic is comprised of model objects, domain objects, things specific to your domain, plus business rules that are applicable no matter what app you're in. So these are reusable. They are app agnostic. They are app independent is the point. Okay. And then we have this notion of data access. This is data, it says access, meaning what is the pattern by which we're going to access wherever our data is stored. And that could be one large database, many smaller databases, file systems. I mean, we're using data in a broad term here. But that concern is where is the actual persistent store of that data? And I don't want a bunch of crossover between these concerns. I don't want the business logic layer to be written in such a way that it's dependent on which database I have. I don't want the rendering layer to depend on the internals of how a model object or business logic thing is constructed. I just want to look at information I can use to help me render, but I don't want to change my world model state or anything. So separating concern is this is a decoupling principle. All right, separation of concerns. It's an architectural style, not a design pattern. It goes across the entire architecture of your web system and families of applications, really. When you separate these things this way, there's a few benefits you get. That decoupling obviously gives you a benefit. It gives you the code reuse and maintenance we were talking about. But it also allows you to apply custom expertise and frameworks to each of the concerns. Customer expertise in that, let's say for rendering you decide that you are going to use Pug, which we'll talk about in a little bit. You're going to write a whole bunch of Pug templates. Well, maybe I just have a certain group of developers highly trained in that templating language, and that's all they do. All right. Maybe I have some folks who understand the business really well and use a particular set of libraries or frameworks to write the business logic. Maybe data access wise, everything we do is going to be using a MongoDB with Mongoose, or maybe a different organization uses Oracle and JDBC and Hibernate and or a Java stack and so forth. Doesn't matter. It's a language independent term. It allows us to say what we want technologies we want to use and what expertise do we want to train up on. And relatively few people actually have to know across layers. All right. So this is kind of the antithesis of full stack. All right. This is saying you can have very specialized expertise and training it at each one of these layers, and they can work relatively independently. Okay. It also allows for greater runtime deployment and flexibility optimizations. Again, considering how you decide to do tiering, right? You can map different things to different tiers, different computational profiles. When I go look at my different tiers on things here, again, what I decide to buy or rent or cloud rent as a server here, and what SLA, service level agreement, if it's on a cloud-based system, or literally what physical server do I use if it's a rack-mounted server that I buy, is going to be dependent on what's the typical processing load of a Node.js server? How many requests are coming? How fast does it handle them? How many network connections? What its computational profile? So you profile these different layers. You look at how much traffic's running through them. You look at how much work they're doing under realistic loads, and you capacity plan for them. And again, if you have separated out these concerns and you've assigned computational resources to each one of these concerns, if you're able to do that, then you have more flexibility and you have more cost control, no matter whether you're cloud-based or not. Okay, that's very abstract, though, I know. Let's talk a little bit more. Let's rewind and talk at the coder level about model view controller, and just use end tier and separation concerns as a bit of a backdrop. I'll bring them back in later. When we talk about design patterns, and I mean gang of four design patterns, we talk about design patterns having these forces, right? These things that compel the need for the solution in a context. The driving force behind the MVC pattern was that coders all noticed their web applications following the common processing pattern. We've talked about this processing pattern, right? 1, process request headers. 2, process request parameters. 3, do some processing, assembling the response payload, setting the content type and other response headers, and writing out the results. Like I've told you, every web application has to do that. Server-side driven web application has to do that. Different steps of the pipeline. So folks, they quickly realize that, but when this first all started, there weren't all frameworks sitting around. So homegrown frameworks became all the rage, right? And they became organized around this MVC design pattern. So what's this MVC design pattern look like? Is a complicated diagram. Came from the Mozilla Developer Network Express tutorial, which I do encourage you to look at. It has two different sets of numbering on it that I'm going to talk about. The blue circles with the red are the steps from the original template pattern. Remember these are the steps. All right, these are the red 1 through 6 over here. All right, these are these here. All right. And then there's another set of circles with a light gray outline. That's a step of the MVC pattern handling. It also has 6 steps, but notice the numbers are in different places. So I'm going to walk you through what those numbers mean. But let's talk in general about what happens here with our pattern, right? We have an HTTP request. So here's the browser sends in an HTTP request. The first thing we do is we hit a routing component, all right? Something is going to determine where the request needs to go. This is also sometimes referred to as a front controller, which is something we'll talk about again in this course. But it's responsible for map, and how's it going to route? It's going to map based on this URL. The URL and other information perhaps in the request. Usually it's mostly on the URL, but there may be other information in the request. It's going to look at that information and say, let me forward the request to an appropriate controller. All right, let me delegate, let me send it off to a controller, and that controller is going to understand how to interact with the model. All right. Now, from our template perspective position, the processing of request headers and parameters happens up front as part of the routing. Part of deciding what controller to forward to, we have to look at what comes in the HTTP request headers and what comes in on the parameters. And let's broadly talk as parameters include the URL. Once we do, we can say, okay, we know where we need to route. We're going to route to this controller. That's this step 3 here. All right. That controller then is going to use the application independent, domain independent model objects and model functions, some of which may interact with the database. Typically your models are objects that represent things that are in non-volatile storage, things in the real world you're modeling. If you're writing something about students enrolled in a class, then this is your student database and your course database and so forth, and you pull things out of the database, out of database rows or documents if it's Mongo, or rows if it's a SQL database, and you turn them into objects and you interact with them at runtime. So all these, the database is a separate tier, right? That's running in a different space. Depending on the complexity of your program, though, all this other stuff, and by all this other stuff I mean every other box here except the browser, this is all part of your node. For us, it'll be all part of one Node.js app. Okay. The controller interacts with business logic and data in the model objects. When processing is completed, all right, so control returns back to the controller. Then the controller says, okay, based on what it was coming in and what needs to be rendered, I'm going to go find the right view, and I'm going to let the view interpret the information that came back from the models. In fact, very often you're given a kind of a read-only projection of the model objects in order for you to fill in what should be rendered out to the screen. And then we'll also write the response headers and send the HTTP response back out. All right. So again, make a message diagram. Let's talk about what are these other 6 steps we're talking about. Well, first let's talk about this design pattern. What's a design pattern? Again, a reusable solution in context. You should have seen that before. That's a reminder. That's a Gang of 4 definition. The context here, the reusable solution in context. The context here is a web application. Our 6 templated steps, right? The solution. These 6 steps, by the way, are the template pattern we've been talking about all along. The reusable solution is the common 6 steps according to the MVC structure. All right. So the MVC is a structural pattern. There are 3 types of patterns, and according to the Gang of 4, creational, behavioral, and structural. So MVC can be considered a structural pattern. And again, this is independent. You're not doing MVC because you're doing Express. It's the other way around. If you're doing MVC, then you may need a framework like Express, but there's plenty of others. There's Happy. On top of Express, there's one written called Sales. If you're overworking in another language, again, like Java, there's tons of frameworks, right? Spring has a Spring MVC and so forth. Every framework has, every language platform, I should say, for the web has frameworks that are expressions of the MVC pattern. In terms of how Model View Controller maps to things like our separation of concerns. First of all, Model View Controller does not equal separation of concerns, right? This is a design pattern. Separation of concerns was an architectural style or set of architectural principles. It operates at a bigger, coarser grained, and more abstract level. But we can view the MVC pattern as one way to enforce or realize or instantiate separation of concerns. In this case, the view from our MVC is the presentation layer. That actually has more of a one-to-one mapping. We'll talk more about that when we talk about the view layer. The model comes from data sources, the world model, meaning that's this part. That's this connection right here I was talking about. But the model itself are a set of domain objects that models the real world independent of an application. So it doesn't one-to-one correspond to a data access layer, if you will. It actually comes more, the model is more roughly equivalent. The model actually typically has the business logic from here, plus the exported data from the data source. The controller actually isn't in the separation of concerns model whatsoever. It's the routing logic, right? It routes requests, which is not business logic per se. Controller is really application logic, right? That routing of requests. Because what is it doing? It's viewing, it's adapting to the inputs, right? An HTTP request is just an input to your application. Just like if you're writing a desktop application and you did a mouse click or something, that is an event that's incident on a GUI object that then you have to determine what listener is going to handle. That routing, how the call gets to what it needs to get to, that kind of traffic cop, that's what the controller is. So it's specific to the application. Controllers aren't reusable across applications. They are specific to the application, whereas a model is not. All right. And by the way, just like I said, you can do this in any language, any framework. MVC didn't start with the web. The MVC pattern has been around in the 70s. It came from the same folks who gave us design patterns, in the Smalltalk community folks. And I posted for you a reading from the late 70s on Thing Model, or maybe it's early 80s, Thing Model View Editor, which is kind of the starting point paper. The first design pattern paper before design patterns were called design patterns, but the first one that talks about something similar to MVC, and it wasn't, we didn't have the web back then. It talks about it with respect to other types of applications. So MVC outdates, has a longer lifetime than web applications, but it's become the predominantly applied pattern for web applications. All right, back to those 6 steps in terms of implementing MVC. And again, these 6 steps, which again are embodied by these color circles, these are different. They are mappable, but different than the blue circles, which came from our template pattern. There just happen to be 6 of each. That's why I'm trying to make sure you understand the distinction. The first thing is an HTTP request is made into the router/controller, and I say router/controller in a bunch of places because sometimes these two are actually kind of combined into one place. They're not always separated. But basically the HTTP request comes in, and you have to process the HTTP request, and you have to route it somewhere. All right. The controller is going to delegate and use the model, the app implication stuff. So the controller is, I said this is app specific, which by the way the router is too, the front controller, and this is app independent. This is reusable. So from a dependency standpoint, the controller's got to know about the model. It's got to know things that it needs to use in the model. So the controller is going to be tightly coupled or tightly dependent to the model, but it shouldn't be bidirectional. The model should not be dependent on the controller. One of the ways you know that is you shouldn't be passing any parameters from HTTP all the way down into some model-driven method. If you got to change model objects to take an HTTP request, for example, then it's not truly a model object anymore. So, for example, consider the microblog example we were looking at. It actually gave to the microblog constructor the HTTP request and response. Well, that was easy to do. It actually really should have copied the information needed out of there, used it in a route, and not just instantiate a blog with all that information in it, if you consider the blog object to be the thing that was the model. Okay. The model then executes the business logic on the world model. The model does whatever it would do no matter what application you're talking about. Again, it doesn't matter if, lost my mouse. It doesn't matter, I need this diagram again. It does not matter if it was the web application coming through the browser, if it was the API making a request, some green screen terminal, a third-party B2B system, or whatever. From the business, from these running functions, services, components, whatever realization they have, from the business logic perspective, something came in via an invocation of some kind, an event, a direct invocation, a method, a message, whatever, and it has to do something and respond with something. All right. And it should do those things in its own canonical way without having dependencies on each individual one. That's why this thing now becomes kind of the center of what we're talking about. That's the stuff that's app independent, but all these other apps have to come in and use it in different ways. Okay, if you're structuring your system very well, if you're separating your concerns well, then you should be able to access the business logic from many applications. And that's always why you hear me say one of the litmus tests for you to know that you're structuring and writing good code is don't just write a web application against it. See if you can write the command line or GUI desktop application or the mobile application against it as well. All right, then you know you have well-structured code if you don't see those kinds of tight couplings appearing out in the business logic such that you can't write that second application. Okay, I'll get off my soapbox and now let me finish this part up. The view is a read-only access of the model. I mean, once we're done, I'm sorry, I skipped a step. First, the model is going to execute the business logic. The controller also, in addition to delegating the right place in the model, it also has to identify the appropriate view template. So again, that is back here, right? This is step 2 is what we're talking about when it delegates off to the model and calls it that domain domain logic, if you will, that application independent logic. And then it also has step 4, which is let's go identify the right view or template to use in order to render something. And then the view will go ahead and access the model or whatever returned from the computation up here, right? It's going to access that and in order to render the dynamic output. What the view basically gives you is a projection of the model. It's by projection, think of it as a filter, a mask. Projection in the sense of a SQL database, like a relational algebra projection, right? You don't see necessarily the full results of the query, you see a projection of the attributes of the query. It's a subset. So we see the view controls that subset of the model that you get to see, combined with what the appropriate rendering format is, right? Based on what the request came in, the content type that the browser accepts or the application accepts, whatever route you're going through to determine, you know, you're returning JSON, you're returning XML, you're returning HTML. So it's part what is the content type returned and what content, meaning what's masked out and is able to be shown to the end user. Big thing though is the view can never modify the model, right? Again, can't say it enough, right? The model is the model's shared, right? All this business logic and data is part of the model. This is shared. So the view, no individual view should be coming in and modifying it. All right. If you're going to modify the state of your world model, then you should have a very specific HTTP way of doing it, a very well identified way in your GUIs, and that information should come in on a request that properly identifies itself as something that intends to change the state of the world model. Okay, and then finally, the view technology typically is going to have some kind of way to write out the final response. Step 6 is our most trivial part. So that is the conceptual overview of MVC. Again, I know I made a mess of this, but I wanted to equate it to separation of concerns and bring that in. I wanted to hopefully clear up misconceptions about what N-tier means. If you hear that term, if you don't worry about it. But the main thing with Model View Controller in the midst of this mess is to understand the flow, right? Your sequence diagram in UML, if you think of it that way, should follow these steps through these identifiable parts of code. We should be able to go into your code. You should go into any code, and just like you were identifying the steps from the template strategy pattern, you should also, in an MVC structured realization of a web application, you should be able to go through and find each one of these boxes here in the code somewhere. Okay, so we'll go forward and talk with how Express does that and identify its parts, and then we'll go forward and talk specifically about the notion of views.